This is Euclid Book 4, proposition number 2, and what we're going to try to do is we're going to try to inscribe a triangle, in other words, put a triangle inside of this circle right here, and the number of degrees in each one of these angles here, that you have angle ABC, you have angle BCA, and angle CAB. These angles here will be exactly the same size as the angles of this triangle right here, which is DEF. Okay? So, all three angles of triangle ABC will have the same number of degrees and their angles than the angles of DEF, which is the other triangle right out here. How do we do this? Okay. The first thing we're going to do is we're going to draw a line from point G to point H, which is going to touch circle ABC at point A. Okay, that's the first thing you're going to do. And then we're going to draw an angle called HAC. Well, here's H, here's A, and here's C. And the number of degrees in this angle is going to be identical to the number of degrees in angle DEF. Well, where's DEF? It's way over here. DEF. So the number of degrees of this angle right here are going to be exactly the same as the number of degrees of this angle right here. Okay? So the number of degrees of angle DEF are going to be exactly the same as the number of degrees of HAC. So far, so good. Now, what about angle GAB? Well, here's G, here's A, and here's B. The number of degrees at angle GAB are going to be exactly the same, okay, as the number of degrees at angle DFE. Well, where's DFE? Well, here's D, here's F, and here's E. So these number of degrees here are going to be exactly the same as the number of degrees of GAB. So far, so good. Alright, now we're going to join B and C together. Here's point B, here's point C. We're going to join them together. Boom. Now, we've already established that line AH, here's AH, it touches circle ABC. Already said that. Alright, and line AC is drawn across the circle. Here's line A, here's line AC, starts at A, goes to C, and it's drawn across the circle. That means that angle HAC, right here, let's say it again, HAC is equal in degrees, okay, it has the same number of degrees as angle ABC. Well, where's ABC? Well, here's A, and here's B, and here's C. So the number of degrees here is exactly the same as the number of degrees here. All right. And we can prove this by Euclid Book 3, proposition number 32. Now, we already said that angle HAC is equal to angle DEF. Well, here's HAC. And here's angle DEF. Okay? Well then, by the transitive property, we can then say that angle ABC, right here, the number of degrees at it are exactly the same as the number of degrees at angle DEF. DEF. Okay. Now, earlier in the proof we said that angle GAB was equal to angle DFE. Well, here's G, here's A, here's B, here is D, here's F, here is E. The number of degrees here equal to the number of degrees here. Now, angle ACB, well, here's A, here's C, here's B. This angle right here is equal in, it has the same number of degrees as angle GAB. Okay? And we can say this by Euclid Book 3, proposition number 32. And therefore, by the transitive property, angle ACB, ACB, this angle right here, has the same number of degrees as angle DFE, which over here is DFE. Okay. And that finally means that angle BAC, this one right here, is equal in number of degrees to EDF. EDF. Let me show it to you again. EDF. This angle here has the same number of degrees as angle BAC. And we can prove this by Euclid Book 1, proposition number 32. And because of this, we can now say that this triangle here, which is ABC, is equal angular to triangle DEF, which is right over here. And that's what Euclid wanted you to prove. I will tell you more in a future video, so stay tuned.